Things kind of lined up for me to get here. You'll note that I speak with an Australian accent because I'm Australian, and being in Ohio is not my usual state of being, but I did make it here. I'm presenting this talk in a 30-minute slot next week at PyCon Australia, so I've been a bit light on details, but I'm going to try and make things up as I go along to try and fill out the whole time slot we have. This 5-minute delay has helped me there. Hopefully it's not too short today. So to begin, I don't actually code Python professionally at the moment, but my ties to the community are mostly as past organizer of PyCon Australia. I'd recommend you attend this conference at some point in your life, but this year's is next week, so it's probably too late for you to get there. So professionally, I work mostly in Android development, working on pure Android apps in mostly written in Java, unfortunately. My main job is working on a large-scale multi-platform app, though, which means I touch code that runs on Android, iOS, Mac OS X, Windows, and sometimes I also write Java services code, which I cry myself to sleep when that happens. Last year I was at PyCon Canada in Toronto, and I gave a talk called The Land That Python Forgot, which was about the state of Android on Python on Android, and various online forums picked up my talk several months later, and I think this comment here summarizes the end point of my talk really quite well. People were very upset. They thought they were going to learn about how everything works absolutely perfectly, and I told them exactly why this was not the case. I had some really good email discussions with Ben Rausch after this, actually, so it's great to finally be in the same forum as you. Basically, in that talk, I concluded that there isn't a good solution for making native mobile apps on Android. The situation is still pretty much the same on iOS. Games where you need completely custom UIs or apps where you don't need to fit in with the native behavior of a system are basically the exception here. So has much changed since August 2013? Well, the answer, as you might guess, is no. So during today's talk, I'm going to be talking about things that are slightly less upsetting. I'm basically going to look at places where Python developers can fit in with the mobile ecosystem. So I'm going to focus on things that you can basically already do. I'm delivering this mostly to a web dev type audience because I guess that most people who are interested in Python on mobile have some sort of experience with web dev. We won't cover too much about making real or native mobile applications because, as I just described, the support really isn't there with the exception of doing things with custom UIs. And I'm going to skew mostly towards Android because that's what I'm familiar with. Most of the things I point out apply equally as well to Apple's iOS. So the three things I'm going to talk about today are web apps and how to make your web apps discoverable on mobile devices, the current state of pure Python applications and where we are with that, and then a quick look at what I call hybrid approaches to making mobile apps that work. So a bit of a recap about what we're actually talking about today. So mobile devices have been around for like 30 years now. Pretty much everyone in this room is going to have one. If you don't have one, I don't understand why you're in this room. So I'm going to assume that you at least have a vague familiarity of what a cell phone is. For a long time, I had one of these. Who else had one? Right, so this was the iPhone of the late 1990s. It was great. It had an app. Snake was fantastic. But in general, mobile devices were just dumb devices for making phone calls, sending texts, and the like. Early last decade, we had this thing called the Pocket PC, which they thought was going to be absolutely the future of mobile devices. It was great. It was like a PC. It fit in your pocket, hence the name. And people made applications for it that were basically just scaled down versions of the programs that you would use on your desktop PC, and you'd navigate it using a stylus. So you'd still pack in lots of widgets at really high densities, and the only way that you could effectively use it was to use a stylus, because that was the only way you could get the sort of precision. The world has since decided that this was a bad idea. These really aren't the types of devices that we care about today. The most important year in terms of mobile, in my point of view, is 2008. This is when the iPhone SDK first came out. It's when the first Android phones came out. And in that year, we basically settled on what a mobile device would look like, and this hasn't really changed all that much since then. So the first aspect of mobile devices that we care about are touchscreens. These are touchscreens that we use with our hands and not with styluses. These have in general required the use of new UI frameworks and design approaches that legacy user interface toolkits and a lot of the approaches for the web didn't really cater for. We have things like software-based keyboards, which means that content panes on mobile apps have to deal with frequent resizing, and users really hate typing on these things because it's easy to make errors. And compared with styluses or mouse pointers, we lose a lot of precision. We have to basically press things with our thumb, and our thumbs are like 40 pixels wide versus a mouse pointer, which is like 1. So that means that we have to approach design in a different way to how we would approach design on the web or on desktop applications. And finally, we have app stores. On Apple platforms in particular, app stores basically define the rules for what you can run on your device at all. On Android, if you try pressing a couple of buttons in settings, you can install apps from anywhere. But in practice, most people find their apps from the Google Play Store. Basically, on mobile platforms today, app stores act as the only way of discovering what things are available for a given platform. So where does Python fit into all of this? Well, as I described earlier, things are pretty bleak still. On iOS, for quite some time, Steve Jobs had this thing against Flash, and he had quite draconian policies about what languages you could even run on an app that got accepted into the App Store. This was basically limiting you to anything that Apple had an official SDK for, or HTML5 apps. And so this meant that basically, as a consequence of banning Flash, Python was a banned language on iOS until about 2 years ago. Python probably wasn't the target. Apple quite enjoys coding Python in the Mac OS world, but they banned it for iOS, which means that we've basically lacked 3 years worth of development in the mobile space. And then who here saw the WWDC keynotes back in June? Well, they introduced a new programming language called Swift, and they engineered a bunch of examples where they draw Python as the baseline, and then would show their existing language as being faster, and their favorite language, the new one that they'd written, as being even faster than that, ignoring for the fact that most people would not write complex sort comparators in pure Python. They'd probably use C. Nor would they do pure encryption algorithms in Python. Most Python developers would know that this is the point where you use a crypto library, which would be written in C and would be faster than a lot of them. So yeah, Apple is kind of hostile to Python still in the iOS world. This is very unfortunate. On the other hand, we have Android. And Android is really, really weird. Google decided they needed to avoid conflicts with Sun and then Oracle when it came to use of the JVM. So they wrote their own virtual machine container called Dalvik. It kind of sort of uses JVM bytecode, but all of the class loading behavior, if you're familiar with the JVM, there's class loading behavior in that. In Dalvik, it is completely different. And what this means is that things like Jython, which works fantastically for loading JVM classes within Python. You basically code Python, but you can interact with Java classes as you like. It's a fantastic tool. It does not work on Android. So it's taken... Let me back up. Google is also a really well-known user of Python, but their Android team decided that Java was going to be the language, and they decided not to make Python interoperable with it. And it's taken quite some time for people who aren't Google to figure out how to make Python run on Android. Indeed, Google have since changed things, but I think the approaches to getting Python working on Android are unlikely to break.
Do you know if this is changing with art?
No, it's not. So, oh yeah, of course. So the question I just had was, is this changing with ART, which is the new Android runtime, which came in the most recent release of Android? The answer is no. They're actually moving even further away from JVM behaviors. But as far as I can tell, the approaches to making Python work on Android will still work under ART. The ART stuff only affects things that are written in Java. So the take-home message here is that mobile platforms have anointed official languages. This is quite unusual compared with the places where people who are familiar with developing Python do most of their work. Normally, when you're in Python, or you enjoy coding Python, you're in a point where you can choose to code Ruby, to code Node, to code Python. And you've chosen Python because you're sensible, clever human beings. In the case of mobile, though, each of the major platforms have anointed an official language, Objective-C or Swift in the case of iOS, Java in the case of Android. And the APIs for these are very, very specific to those languages. And re-implementing the APIs in something that's not Java or Objective-C would be quite time-consuming, it would be quite difficult, and it's a huge task that I don't think any sensible person doing an evening open source task would really want to do. But the other thing is that mobile is interesting because operating system vendors have really, really clear ideas about design standards. So official APIs, which require the official languages, tend to keep up with the design standards that each of the platforms promote. Android is in the process of changing their design guidelines. iOS did a massive change last year. The official SDKs for these platforms supported the new design standards out of the box, whereas every other toolkit has to play catch-up here. And finally, there doesn't really appear to be all that much work on targeting Python on iOS or Android from a commercial point of view. Everything seems to be commercially driven. This is not such a bad thing, but the mobile industry is very much something that's having a lot of development money poured into it, which means that Python at the moment is not something that has the same level of drive as the official languages. So in summary, mobile is unlike anything you've written user interfaces for before, and Python is being artificially disadvantaged by the major operating system vendors. So this is kind of unfortunate. So the rest of this talk is basically a grab bag of things where Python can fit into the mobile world. The first thing I'm going to talk about is the web, because my guess here is that most people who are interested in producing consumer-facing applications in Python are already interested in the web. Am I right here? Who here does web stuff? Right, about half the room. So I'm going to give a quick overview here and some pointers as to how web developers should approach mobile. Now, if you're a keen observer here, you'll note that I'm not actually going to be talking about making your apps in Python. And the reason for this is that if you're doing web front-end stuff, you're probably writing stuff in JavaScript, so you're not actually a Python developer anyway, so we're not losing anything. So the key difference here between designing for full-size computers with a big screen versus mobile devices with a small screen is to actually consider how your design will work in touch-driven contexts. Because when you're touching things, you don't have things like hovering over. You also lose the precision when you use your thumbs to press things as opposed to a mouse. So touchscreens, as I just said, don't have a whole lot of precision for being able to touch things. So it's also quite difficult to tap on things precisely. So if you've made a website which packs a lot of links into the same place, well, that's really difficult to use because it's hard to get the precision to touch on the right links. This is a screenshot out of Google's Android design guidelines, and I'm going to try and turn the lights down so you get a bit of better contrast there. Is that going to work?
That's mainly for your lectern. I'll turn off the light.
Okay. No, this one seems to work.
Okay.
This one's for the lectern and that one's for the house lights. Unfortunately, it hasn't got much better, but you can see that there's an outline here of a button, and there's an outline here of a button that would appear if you take a look at the slides later on. This is called the 48 pixel grid, which is a nice rule in Android. It basically says that if you think of your designs as being laid out in a 48 pixel grid, you can figure out how to adequately provide enough space between tap targets for things. So with this button, there's a 4 pixel border between it and the next thing. Likewise with the 32 pixel button, which you can't see, but look for the number 32 and you'd probably be able to see it on my screen. There's a border between that as well, so you can make sure that it actually gets touched when you put your thumb there. As a rule of thumb, things should be about 32 pixels wide in every dimension at a minimum to make sure you can adequately touch it. Now, cell phones are operated with hands. You might not have noticed this before. And hands, as you might also not have realized, are things that you can't see through. If you have your hand in front of a screen, you cannot see where your fingers are, or the bits behind where your fingers are. So you should design to make sure that things that are at the top of your screen are things that don't require you to be able to see what is below them, because you will have a thumb there. This is a kind of important thing. Now, there's a meme going around in the web design community about this thing called responsive design. I really hate this term because it's a nice word that doesn't really mean anything. I'm going to call them constraint responsive designs, which is basically designs that alter themselves when the visual constraints of a design change. So if you're doing CSS stuff, this is having different layout definitions depending on what sort of width or height you have for your screen. Now, this is actually more important than you would think on mobile, because even if your phone is in portrait, you have to deal with keyboards popping up and stuff like this. Basically, your dimensions can change quite frequently, and this will drastically limit the space you have to display things. As an example, you can see that on this portrait view, half the picture has been cropped. If a keyboard comes up, you lose about a third of your total available height with a keyboard open. Now, in landscape, you end up getting a lot more width, so you can actually read everything. But then if the keyboard comes up in that, you lose half of your screen. So making sure your designs are responsive to constraints is quite an important thing to do. You should adapt to the available space that you have. Now, web apps have a massive disadvantage when it comes to apps that are packaged for a mobile platform. The web is actually a really hostile place on mobile devices because we're used to navigating using URLs and stuff like that. Now, mobile devices are really, really hard to type on because you have software keyboards. They're really inaccessible. It's easy to make errors, and you need to get URLs absolutely right. So, to give you an idea of making the PyOhio website accessible in the same way as I would make an app accessible. So to do that, I have to open up Chrome on my Android phone. Then I have to start typing a URI and get that absolutely right. Then I have to wait for the page to load. Then I have to press a bunch of link targets to find the schedule. And then I get the schedule and I press the context menu and I select this add to home screen thing. And then it finally appears on my home screen, and you can see it right here. It's there. It's got this fantastically obvious icon, which is a square with a world inside it. That means Pi Ohio. Basically, if you don't have a favicon, you won't get an icon when you add it to your home screen. And then when I press that again, basically I go straight back into Chrome, which is not really how I expect applications to behave. As a comparison, finding something on a Play Store, quite easy. You search for the thing you want, you select the app you want, you press install, and there it is. And it has an icon. So the rule here basically is you should make it easy to find your apps. If you want to be found on mobile and you must use the web, make it easy to find them. So package it up for your preferred platform and put it on the App Store or the Play Store if you're on Android. That makes it easy to find, and you'll be on an even footing with people who have packaged up apps for that specific platform. Now, for bonus points, you should make your web app behave a bit more like mobile apps. The first way to do this is to write a simple app in your platform's preferred toolkit that wraps your site in a web view. Just doing that on its own, though, is a bit lazy. You need to do more for your app to be not an awful thing to use. And this is about meeting users' expectations. Mobile devices and mobile apps have a sort of set way of behaving. So, for example, if you pause an app on iOS by going to the home screen and reopen it, within reason, you'll go back to the same screen that you're on before when you left it. This is a similar thing on Android. If you press the home screen button and reopen your app through the recent applications list, you'll end up where you were beforehand. And this is not something that will happen if you just simply wrap your website in a web view. So there's basically three things you need to do in this case. You should remember stuff across sessions within your wrapper. You should remember where you were in case your app gets backgrounded, it gets killed. That's a thing that can happen, and your app needs to reload again. And they should function well offline. And as it turns out, HTML has good support for offline now, so you should go and use that stuff. The most important and difficult thing here, I think, that most front-end developers don't pay attention to is making it easy to get back to a given point within your application. It's actually pretty simple to do this if you make sure that you identify every state of your front end with a unique URI. That way you can attach a listener on the web view on your preferred mobile toolkit that stores that URI every time it changes, so that when you open the app again, it goes back to that state. And that will make your app behave a bit more like an actual native phone application. There's also toolkits like PhoneGap. That is the word PhoneGap written in a gap in a phone. Right. PhoneGap is good because it gives you a relatively simple way of wrapping applications, wrapping web applications up in a way that is consistent with your preferred toolkit or your preferred platform. Try it, your mileage may vary. I find it a bit bloated for cases like this, but it does work and it does make things easy. So in summary, lots of people, myself included, might say nasty things about web apps on mobile. The truth is that if you play nicely and behave like a mobile application, people won't care too much if your web application is a web application. Just make it accessible and make it discoverable on your preferred platform. So the next thing I'm going to look at briefly is this idea of writing apps fully within Python. And unlike last year when I did a survey of a bunch of tools that were available, including Qt and Pygame, there really is only one contender these days, and that is Kivy. Every other option I've seen doesn't appear to be making any real progress, but Kivy seems to be making a lot of progress now. But I'm not going to spend a lot of time talking about it because Ben gave a much better talk on this yesterday. So if you weren't at Ben's talk yesterday, catch up on the video. But to give you a quick idea, Kivy is actually two things. First up, it's a pure Python UI framework. It has custom widgets, and these widgets behave relatively consistently across iOS, Android, macOS, Linux, Windows, all those sorts of things. It supports both point and click with a mouse interfaces and touch interfaces. And touch is where it gets most of its interest because, well, it's a pure Python thing that works on Android. The other thing that they do is they work on projects for actually deploying Python onto iOS and Android, which is where I think the majority of their interesting work is. But I would say that. So to give you an idea of what Kivy is if you're looking to make an app, Kivy is really good at doing fully custom UIs. This is where you don't care about replicating the native look and feel of your system. Lots of people care about being native, but if you're like a game developer or if you want something that looks radically different to your platform's preferred UI style, then Kivy might be good for you. In general, this is a good thing if you're aiming to run the same UI on multiple platforms, particularly two platforms where you use the same input style. And now to look at what Kivy doesn't really let you do. And like I said, the first thing is that it doesn't let you do native UIs. So if you're looking at something that implements the native iOS look or the native Android look, this is not the tool that you really want to use. If they do any level of replication, it's basically through imitation, and if the platform changes how it looks and feels, Kivy is going to lag behind that, and they won't be quite as good as the official widgets. But like I said, games and stuff like that, Kivy is a really good option, and I strongly urge you to check it out. Games, freeform UIs, stuff like that. I also suggest that Kivy is not great for doing an app that runs on both mobile and desktop, because the requirements for design on mobile versus desktop are completely different. On a desktop application, you have lots of space and you want to make sure that all of that space is filled, and you can point at things with relative precision. On mobile, you need to make sure that it's obvious where things are tappable and have really, really sparse navigation elements so that you don't press the wrong thing. Kivy will let you write an app that runs on both Android and Windows, but I don't think this is something that you want to do. But then again, your mileage may vary. One thing that's substantially improved over the last couple of years is access to hardware APIs from within Python. Things like geolocation, accelerometers. These are basically the things that make mobile interesting compared with desktop devices. And Kivy has solved this problem pretty much as well, which is nice. They provide two projects, one called PyGenius and one called PyObjus. PyGenius automates accessing Java APIs from within Python. It lets you get to most of the Android SDK from within Python in a pure Python context. And PyObjus does the same thing with Objective-C. So PyGenius requires a lot of boilerplate. You need to derive from Java things. You need to specify specific interfaces, and you need to understand how the JNI works if you want to do this yourself. And things are pretty similar with PyObjus. Objective-C method calls don't map very well to Python because they're really, really weird. They sort of intersperse method names and parameters, and the parameter names correspond to the method names, but they're not the same thing as name parameters in Python. It's all very, very confusing, and you kind of have to hit yourself over the head a couple of times before calling Objective-C methods from within Python actually makes any sense. I really don't recommend it. The good news is that the Kivy people are the sort of insane that we want, and they've produced a new project called Playa. Excuse me, if you're going to take a call, could you walk out of the room? Thank you. Plier is nice. Sorry for video people if that was a bit confusing. Somebody was taking a phone call in the room. I didn't just freak out randomly in the middle of a talk. This is a confusing thing for people watching in videos. I will provide commentary wherever possible for these sorts of things into the future. Now, Plier is really nice. It gives you an API where you can actually talk to Python APIs, and they do the relevant Java or Objective-C calls for you, so you don't have to learn obscure APIs for every platform that you target, and that's really nice. So the final frontier of mobile dev in Python is being able to write native UIs from within Python. For me, this would be fantastic because it would mean I wouldn't need to write Java in my day job, and that would make me a very happy person indeed. So like I said earlier, Kivy provides APIs for talking to the SDKs for iOS and Android, but they don't quite get there. On Android, basically, it looks like PyGenius has been written to solve the hardware access problem for Kivy, and it's not really trying to solve the create a UI problem because Kivy has its own widget toolkit. So if you need to access read-only classes from within Java, then you're fine. But if you need to extend classes, which is something that you need to do to make a native Android application, you're really not in luck. And if you're familiar with iOS development, the interface builder action and outlet tasks don't exist in PyObjects. So that means you can't make UI actions work. One thing that somebody pointed out to me in the release of iOS version 8, the betas, they've actually silently introduced a Python framework with the iOS SDK. This was done silently, mostly because they were sledging Python in the keynote. So they're not going to say, hey, Python is terrible, but we're giving you first-class access to it now. I haven't taken a look at this. I know that it's there. Someone should go and check out the documentation and see what you can do with it, because actually writing pure Python apps for iOS would be really, really cool. You can write pure macOS apps in Python using the PyObjective-C bridge. That historically hasn't worked on iOS, but maybe they've made that work. I'm not sure. So the final thing I want to touch on is what I call hybrid approaches. This is approaches where Python ends up being a large part of the overall product, but Python does not provide the UI, which is basically a matter of exploiting things that Python is known to be good at and to defer to other languages where Python isn't really an option. So the first option is to make the majority of your application's logic available through web services. So if you spend time writing a really rich API that exposes most of the information that you need to display on a remote server of some sort, and then format them so that it makes sense to your application, then all you have to do in Java in Objective-C is write the code that displays it, which is cool. There are some pitfalls here, of course. Cell phones in particular have really sensitive bandwidth requirements. Generally, you have to deal with high latency and unreliable variable levels of throughput. So it's rarely a good idea to rely on huge response sizes or huge request payloads. The bigger either of these are, the more likely it is that you won't succeed in making your requests and things will fail. So making sure that no particular request is the request that makes your entire application work is important. Make sure that everything is repeatable. Now, users are funny people. They enjoy putting their devices out of cell phone range. So you need to be able to deal with variable levels of connectivity. Now, we know that San Francisco Bay Area has a monopoly on mobile design at the moment. So this thing is called BART testing. Take your code onto your favorite subway system and see whether or not it works while you go in and out of tunnels. Finally, you need to make sure that your app is able to communicate what information it has. You need to ensure consistency between the device and your server. There should be no arguments between what the server thinks the device has and what the device actually has. Now, I've given a talk on this in much more detail where I talk about design for mobile web services and making things not suck for mobile developers if you do web service stuff, where I talk about what I've just said in a lot more detail. I highly recommend you check that out. The other approach that I want to discuss briefly is this idea of a hybrid app. This is an app that has multiple languages. The idea being that you write the majority of your app in a cross-platform language like Python, and then write specialist UI code for each platform that you target. So how this looks then is that you use Python for your core code, you write it in Python for both Android and iOS, and then you write a new UI layer for both iOS and Android. Now, I'm not entirely certain whether or not this approach works out of the box. In particular, I think that this should be doable because we already have working embedding code for Python on Android, Python on iOS, thanks to the Kivy guys. But this approach for structuring your app works in general. My day job, we do this in C++ instead of Python. And I think it's a really good approach for ensuring code reuse. But if I needed to start a new project where I needed to use C++ again, I absolutely would not do it because it is a terrible language. But I think the Python is the best equipped language to do this. So go and check to see whether you can actually call into Python from Java or Objective-C, because I think that would be a cool thing to do. So this is basically the end of the talk. So to summarize, there hasn't been much real progress in getting full apps that fit in with the rest of the system working on Python, and this is kind of sad. But I still think there's a place for the Python coder in the mobile world. So web app developers who are writing back-end code in Python have an option to target mobile. They should pay attention to how mobile works and make sure their web apps work nicely. There's really good support for partial pure Python, partially native apps written entirely in Python thanks to Kivy, and there are approaches that involve using both Python and other languages. And that is the end of the talk. I'll now gladly take some questions. Yes.
Can we get to that other URL from that link right there?
Yes. For that, you will need to learn how to spell my surname, which I believe is a public service. Anyone else?
You used a word I'd never heard of before, and something like quadroponian. Does that ring a bell?
Nope.
What's the most similar word?
I'm not sure I can remember what.
It's okay.
If you can.
Used in a negative context.
Interesting. No, that doesn't ring a bell. I'm sorry. Anybody else? No complaints.
Have you tried Pythonista on iOS?
I have not. The question was, have I used Pythonista on iOS? What does that let you do?
Python on iPads and iPhones?
Okay, well, no, I haven't used it. But if it works, then it works. I'll need to look into it. Yes?
So I just want to clear, you said that you haven't used Python purely as like a hybrid application. You haven't used Python yet for like your service part, and then using Java or Objective-C for your front end.
Yeah.
But you've used another language, so you assume through Kivy it would be possible to do the same thing?
Yes. So the question was, where I said that designing hybrid applications using Python as a core language and specializing the UI, I said I haven't done it, but I have done this with C++. Am I just assuming that this would work with Kivy? I think yes, the approach should work. I'm not sure whether or not actually initializing Python from within Java as opposed to writing a pure Kivy app would work. That's something I need to look at. Ben's looking confused.
Yeah, I'm thinking about it. I'm not sure.
So it's not a thing that I think the Python for Android guys have actually thought about yet, but it should be something that could be done fairly trivially.
Yeah, for
Yep.
Python for Android and PyGenius, they're both not tied to Kivy intentionally. We did that so people can use, Qt and still use those projects to do it.
So Ben points out that that PyGenius and Python for Android, while being developed as part of the Kivy project, are not tied to Kivy. So you can use Python on Android in non-Kivy contexts. Yes?
Have you used the Swift over the Objective-C in the iOS development, and if so, what are the differences?
Between Swift and Objective-C, I'm not really the best person to ask for that because I primarily develop Android and Swift is still in beta, so it's not really a thing that I'm familiar with at the moment. I can tell you that it's a nicer language to code in. You don't have to do the funny square braces that you need to do in Objective-C, which confuse everybody when they see it. It feels like you're coding in a modern language, apparently, which will be nice once everything supports it, but everything does not support it at the moment, and you'll probably still be writing quite a bit of Objective-C in iOS applications. So Python still has a chance to fill that space, at least partially, if we can get to the point where everything works. And that would be cool if we had a large number of Python apps targeting iOS in the near future.
Are you going to post your slides to that URL?
I will post my slides to SpeakerDeck and we'll make it available there, yes. You?
Do you know if you can make those WebView wrapper apps in Kivy?
I don't think you would want to. The reason why is because Kivy, the distribution of Kivy requires you to embed a Python interpreter in your packages, which adds some 6 megs to your package size. So unless you actually want to make an app in Kivy, it's not something that you should use just for the sake of it. There is also a startup cost involved in Kivy because it has to load a substantial amount of machine code on startup and get a Python interpreter running. If you're just doing it in the platform's native toolkit, you'll get a very small package and it will load quickly and will take you straight to the web view that you want, which is why I recommend that approach and not doing it within Kivy. Yes?
I may be taking you a little off topic, but
Please do.
my background is doing Python Django, and some command line Python. Is there a GUI front end for Python? Is there a
Oh, so for mobile applications,
well, even for just desktop applications?
Kivy is the thing to look at.
Okay, because like I
So
said,
if I
it's all in command line for me.
Right, if I didn't make it clear, Kivy has effectively 2 roles as a project. One is making support for mobile platforms such as iOS and Android, and the other is in producing a user interface toolkit that can run on mobile and can run on desktop platforms. And by all accounts, it is quite good. Check out Ben's talk from yesterday on the videos if you want to see how that is done.
And I know there are at least 2 Python repos in Google Play Store.
Yeah. Anybody else? Well, thank you for coming along. You've been a fantastic audience.